So let's get ready to render this guy. The first thing that I'll do is set a null down here to be where this guy is going to get rendered, and we'll say render out just for nice clean organization purposes. Also, I'm going to want to be able to split up the material between the eye and the pupil and the body. So let's actually go back up here to where we kind of created those groups and move it so that that happens back here before it kind of propagates down to the rest of everything, including our kind of underlying guy down here. So we'll do that. Another thing that we should do for good measure really quick is just cache this vellum sim. So I'm going to go ahead and drop a file cache node in here, and I'll call this mega sim, and I will change this to say mega character, just like we did before. And since this is going to take a little while to cache anyway, I might as well just kind of increase the quality a little bit. So let's give it 2 sub-steps instead of 1. Let's also go back to the remesh node up here, and we will set this to have a little bit of a higher resolution proxy mesh. And let's also go back into the scatter over here, and instead of having 1,000, let's maybe do 1,200, which will maybe help fill in the gaps just like a little bit more. And then I'll go ahead over here and I will hit save to disk. So I'm really liking this, and I'm thinking we're ready to hop into rendering. Definitely got a little bit more of what I wanted, and the arms and dangly bits on the individual guys are kind of like following the overall motion a little bit better now that it's a little bit less stiff and a little bit more squishy. And then the floor guys kind of squish better against the floor in a fun way. So I think this is great, and I think we're pretty much ready to hop into rendering. One thing I'll do real quick also is check this guy to use as reference, because this guy is nice and fast to play back in the viewport. And I just want to add a grid onto the ground, and I'll make sure that I'm in wireframe view mode. And I want to make sure that this ground is sort of moving with my character. So we want it moving this direction. I'll add a transform node, and we will translate it in this direction. So I'll do -@time, and just through testing, I've found that this floor will move too fast by default, but if I multiply it by 0.3, I end up getting, you'll see that it looks like the feet are kind of planted on there more or less correctly. It's not, you know, quite too fast or too slow. Just a sort of quick little floor. And this way also I can copy to points a bunch of random geometry if I wanted to have like bushes scattered along the floor or something like that. And you know, I'll increase the size of this a bunch. Then we have our scatter, and we will copy a bunch of boxes, just for example, onto here, and merge it with our ground. And let's make this box a lot smaller. Yeah. And now that can be something that our character is kind of moving with. I think what I'll end up doing is probably just moving, switching these to something like spheres, and changing the scale and setting this to polygon mode. I think I also want to maybe like blast away the center part, so that it's not creating just like a path for our character to move in. Whoops. There we go. We will have these guys scattered over here, maybe less dense to make it feel more random. Yeah, like that. We'll scale them up a bit. We'll add some noise, mountain sop onto these guys just to make some quick sort of random procedural bush type things. And we can also copy and transform these a bunch out. Let's just copy them backwards kind of to infinity. I think actually what we can do here is transform this guy up a bit. Let's say maybe like 10x, boom. And actually we don't need maybe 20 copies of this back. Let's do 5, and then we will transform this whole thing to be further over in this direction, so it kind of already starts with some space here. And then, in the interest of kind of making this composition nicer, I'm going to bend everything after the fact. And let's take a look at this bend deformer. So I want to bend it down like that, and I want to deform it in both directions. And I'll increase the capture length of this bend. And now he's going to walk through this scene, and this looks pretty sweet. And I can just literally add a sky and some clouds, and I'll have kind of a cute little composition here, I think. Let's go back into the character object, and I will just have the display flag on here so I don't have to worry about this actually calculating in my viewport, and I can just use this kind of in the viewport as a proxy reference thing. And we can hop into Solaris to start lighting the sky. So we're in Solaris. I switched to the stage context and I switched to the Solaris desktop, and we're ready to start lighting. I'm gonna bring in my SOP import, and we will grab from our character object the render out null, and that will bring in our mega character. And you'll notice over here we have the scene graph tree, which is sort of like our geometry spreadsheet in Houdini. It gives us sort of all the info on all of our different USD objects. And what I want to do is see in here that I have all these different attributes that come in as these things called primvars. So you'll notice I have the P capped frame, FBX translation, FBX scale, FBX rotation attributes, which are all just attributes in SOPs. And then I have this display color one. This is what CD, the point color, becomes in USD, is display color. This is a USD convention, and this will be important in a second, but it's just one of these quirks of USD that I want to point out, which is that when you switch from regular Houdini into Solaris and we're working in USD, CD becomes display color, and there's a few other little quirks like UV becomes ST instead, and I just wanted to sort of make you aware of this. So we'll go ahead and drop a material library so that we can start setting up a material on our character, and I will dive in to start building that. So now that I'm in here, I want to drop a MaterialX subnet. We're going to build our materials with MaterialX. And I want to do this because MaterialX is supported in Karma as well as Karma XPU, and also theoretically will be supported in a whole bunch of other render engines once they add support for MaterialX, which I believe a few do already. So once I dive into here, we'll see I have a surface output and a displacement output, and I can plug some different BSDFs and things like that into this MaterialX surface. Or I can delete this and I can grab a standard surface node and I'll plug that into the output instead. This is an Uber shader, just like Arnold's standard surface or Redshift's Redshift material or the principled shader in Houdini. So we can use this. I'll also drop a primvar reader, which is like a attribute import node. I can set this to be a vector 3 and grab my display color attribute and plug that into the base color right here. So great, we have the basics of this material set up, and I'll now drag this MaterialX subnet onto my character, and I'll have it set as material on mesh 0. Mesh 0 is the name of our mesh, but one thing worth pointing out is that if you want to split things up and give different objects, different materials in USD, you want to give them different names. So we can actually do this real quick by switching back to the object context, and I'll go over here and I'll give it a name. And in here, I'm going to give a name to our mesh 0, which is everything but the eyes. And I'll just call that character. And I'll add another naming. We will give our eye the name eye. And I'll add another naming. And we'll give our pupils the name pupils. And now we have these 3 different things that we can separately apply materials to in Solaris. And so I'll dive back into the material library and I'll drag this MaterialX subnet onto here. And I'll say set as material on character. And I'll also make another MaterialX subnet for the eyes. And I'll make another one for the pupil. And I'll make another MaterialX subnet for the eye, and I'll make another one for the pupil. And in the eye one, I'll maybe set the specular roughness all the way down so it's fully reflective. So great, now I can go back up here, and on my assigned material, I have my character grabbing the MaterialX subnet, and I want to add another one, and I'll say let's have our eye grab our eye subnet, and I'll grab another one and I'll say let's have our pupils a pupil subnet. Awesome. So this should be good to go. So let's switch to Karma and see what happens. And it looks like this is correct. We are in fact seeing our pupils and our character's body and our eye, and that's all really awesome. Another thing that might be nice would be to maybe add a little bit of bump or displacement to our characters' bodies to make them not perfectly round and shiny. So in order to do that, I think we're going to want to have maybe a rest attribute on our characters. So we can set that up really easily. Let's first put a rest position up here, right before the point deform. And I'll go back to Solaris, and then back in our material library, I'll change the name of this to character, and we'll make sure that that correctly gets changed on here as well. And then I'll go into here and I'll grab a USD primvar reader to grab the rest position. And we'll see again, if we look over here at the character, we do indeed have a primvars called rest that we can then use to drive things in our shader. So I'll add a MaterialX noise 3D, and I'll plug this into the position there. Let's use this to drive our bump map. So 2 things that we'll want. One is a multiply so that we can control the scale of our position that we're feeding into the fractal noise. And then we'll also want a height to normal, which we'll use to convert our grayscale map into something that can be used to change the normals on our geometry, and then plug that into the MaterialX standard surface. So you'll notice immediately that this makes things kind of weird, and that's because of a few things. One is the amplitude of our bump map, and the other is because of the scale of our noise. So we can fix that. So we'll go up here and we'll make the scale way bigger. Let's make it like 400. And now you'll see the normals are really getting messed with. So we want to way turn down the amplitude of our bump map. So let's try something like that. That is not bad. That's like kind of a nice amount of skin bump. Maybe let's go even less than that. Let's go real subtle. Let's go 0.005 maybe. I feel like that's kind of good. That just gives it a little something extra. So great. We'll jump back out, and let's also add another SOP import to bring in our ground. And I'll go grab the grid object and my ground render null that I made, and I will merge these two together. And over here in the material library, I'll create yet another material, and we'll call this one ground. And we'll do basically the same thing, except for the display color, we're just gonna set this to be green. We'll go in here and make this something like that. We'll turn this down a little bit. And yeah, we'll leave this like that for now. And we'll drag this onto our mesh 0, our ground. So cool, now we have our ground and we have our material assigned down here for that. So cool, we got our ground, we got our character, we're good to render, right? Well, obviously no, we need some lights in here. So let's go ahead and grab a environment light. And I already downloaded a HDRI that I like, but you can go ahead and download an HDRI of your own or use one that you already have. So let me just grab that. I got this HDRI from HDRI Haven, which is a free resource online. I also, now that I can see this lit a little bit, I want to definitely go in and adjust my ground material a bit. So I'll go back into that material builder and I will change the specularity. I'll bring that specular way down, maybe increase the roughness slightly. I think another thing that we could do, just for fun, is instead of using this to drive the normals, just use it to straight up do displacement. And in order to do this, we're also going to want to have a rest attribute on our ground geo. So I'll go ahead and I'll add a rest position right here before it's animating it all. And then I'll go back out to the stage and I will switch to the material library. And in the ground, I'll just go ahead and plug this into the displacement. And there we go, instant grass. This is exactly what we want, right? Well, yeah, let's obviously go ahead and turn down this amplitude significantly. And I don't know, maybe we could have a little bit more amplitude than that. Yeah, that's feeling a little bit more grassy. Let's go back to where we're lighting up here, and I'm gonna move this HDRI dome around a bit because I'm not super psyched with how this is looking right out of the box. And I want to set it up so that I'm only actually seeing some clouds behind my character. This is already looking a bit nicer. Yeah, and we'll set up the camera as well. Let me do a new camera. And I'll change the focal length on here. And we'll move this back a bit, tilt down. And this is feeling pretty mega now. This is pretty good for our mega character, I think. So I think that's covering most of the bases of what we want for our render. I'll go ahead and drop a Karma node here. And that way we'll be able to add some render settings and export this guy. We can also switch it to XPU over here. Another thing that I'll do, drop a cache lop, which is going to help me create motion blur on my character without having to have a velocity attribute properly set up. So I'll switch to this cache rolling window of frames mode right here. And then what this is basically going to do is cache the previous frame, the frame that I'm on, and the next frame, and thus be able to correctly calculate the way that the motion blur should be generating on every frame that's rendered. Then I think one of the last things that I want to do is set up some depth of field correctly on here. So I'll zoom out and grab my focal length here, or focus distance rather, and pull that out so that it's right on where our character is. And let's switch back to the camera. We're also going to want to go into the sampling tab and turn on the f-stop. I think if we set it nice and low, it'll give us some depth of field on here. So now we see these foreground bushes are out of focus. I also don't mind this background, but I want it to be out of focus as well. So in the dome light, I want to render the background. So what I'm going to do is I'm going to switch to the Karma tab, and I'm going to go down here and turn on render light geometry, so that the light geometry, i.e. the HDRI, also gets rendered into the shot. And I'll tweak the depth of field a little bit more. Maybe we want a little bit more. Yeah, now this guy's nice and in focus and everything else is out of focus. This might kind of do the opposite of what we want in so far as making the character feel like it's kind of miniature, but I also think it's kind of a nice look. So I don't know, maybe we'll go back to where we just were with 0.001. And yeah, I think that this is pretty much ready to render. The only other things that I'll do in here is crank up the sample settings. So I'll just turn this up to, I don't know, something insane like 512. I'll use the XPU engine to render out my final version. And we'll see kind of how quickly I can get this rendered. And here is our Karma XPU rendered mega character. And this guy's looking pretty good. There's definitely a lot more that we could do here in terms of adding actual grass, adding clouds, adding more of these little characters in here. But I think this kind of covers all the bases that I wanted to cover with this course. A few things that I want to add that are just little tweaks that I made in sort of testing the rendering is that, one, I increased the diffuse limit to get a little bit more bounce lighting within the character to 4. So there's 4 whole bounces going on here. In the material library, in the character, you'll notice that I disconnected the height to normal bump map setup here. And this is because, unfortunately, on XPU, the bump mapping was acting a little bit weird. And it works great on regular old CPU Karma, but on XPU, it seems like it's not quite there yet. I'm not sure if this is a limitation as of now or if this is a bug, but hopefully soon that will be in place. But at the moment, XPU is still very much in alpha, so it shouldn't really be used for production yet anyway, but it was fun to use for this little project. Another thing worth mentioning is that XPU doesn't support subsurface scattering, which is why I didn't really bother doing any subsurface scattering on this character, but is something that would be nice to add in theory, since it's, should in theory be skin in this character that has light that's sort of bouncing around within it. And it would be cool to see the subsurface scattering on these little dangly bits, but this rendered much faster without having stuff like subsurface scattering. Another thing I'll point out is that the displacement, I ended up playing with these settings a little bit more here on the ground. So I changed it so that we're doing a 100x scaling on the noise, and I found that this was creating issues for me when I went beyond this in Karma, both in the Karma CPU and XPU, where as the points got further away, the noise would kind of change and glitch out a little bit. At this setting of 100, and by increasing the geometry dicing using a render geometry settings from 0.5, which is the default, to 1, meaning I believe that for every pixel, the geometry is being diced into a single micro polygon, it ended up being nice and smooth and stable. It took a bit longer to render that way. Without increasing the dicing, I was getting about 30 seconds per frame, and when I increased it, it ended up being about 3 minutes. I also ended up not having any kind of interior for this character. I didn't end up using either of those two inputs on the character itself. So if we go back into this character here, we'll see that we actually just have it going straight from this point deform setup into this merge. So again, I didn't use this method for point deforming some interior dings, although that could have potentially worked. And I didn't use this method of having this sort of interior big ding. I didn't like seeing it kind of come through, and I found that I just think that this looks really good as is. The kind of gaps in the character don't really bother me, and it just looks great once you have the lighting that kind of gives it the proper amount of depth. Seeing the mouth open and all that stuff is really nice. And that's it for my Houdini Mega Character tutorial. I hope that you enjoyed it and that it was helpful. And I hope to see a lot more people doing character work, from procedural character modeling and design to kin effects and procedural character rigging and animation, as well as more people playing around with Karma XPU, Solaris. These are all tools that I'm really, really enjoying and have been absolutely game-changing in my workflow. So again, thanks so much for watching, and happy Houdiniing.